So I get this problem for all positive integers AB, such that we have this following equation. We have the difference of two cubes equals the product AB plus number 11. Okay, so the question unsatisfying. Okay, what I mean with this question, does this equation accept the solutions? Okay, basically this expression is not clear enough to see this left hand side of this equation is satisfied the right hand side of this equation. Okay, so you guys, you can give the hands to this problem prior getting to a solution. Go ahead, pause this video when you come back to see the full solution. Okay, so let's go through this one. So I have this following equation. I have a cubed minus b cubed equals ab plus number 11. Okay, we are going to factor out this one since we have the difference of two cubes. Okay, so let's do that. So I have a minus b factor a square plus ab plus b square equals ab plus number 11. Okay, again this quantity is formed with three terms, so it looks like it's a perfect square but it's uncompleted square here. But since we're missing number 2 here, so we are going to put it on the form of the quantity square, so by adding something. Okay, that's what I'm going to do now. So I have a minus b, this one is going to be a minus b quantity square. So if I'm going to expand this one out, I get e square minus 2 times ab plus b square. This one is good, this one is good, but this one is giving us minus 2ab, so we need to add 3ab plus 3ab in order to cover this one. So equals to ab plus 11. Then since I get here a minus b and we have ab here, so I'm going through the substitution. Let's set ab equals m and the difference a minus b equals n. Okay, before we continue solving this one, I'm trying to go back to the previous equation. So if you take a look carefully at this left hand side of this equation, so since we are dealing with the positive integers, so we know the right hand side of this equation is strictly positive, which means the left hand side of this equation must be positive as well. So this one is telling us a is bigger than b. Okay, so a is bigger than b based on this information that we have. Okay, so which means a minus b strictly superior than 0. So I get that this difference is strictly superior than 0. Also this one strictly superior than 0. Now I'm going to replace the difference a minus b with n and the product ab with m. So I get this following equation. So the equation is going to be in terms of m and n. So we'll have n factor n square plus 3m equals m plus 11. So I'm going to distribute this one. I get n cubed plus 3 times mn equals m plus 11. I'm going to move over this m to the left hand side of this equation and take m as a common multiplier for these two terms. So I get here m factor 3n minus number 1 equals 11. Then moving over this n cubed to the right, I get n cubed here. So this one is telling us m equals 11 minus n cubed is divided by 3n minus, since m is a positive integer as we have here, so which means this one must be strictly superior than 0. Also denominator must be strictly superior than 0. So which means 11 minus n cubed must be strictly superior than 0. In the other word, 11 must be bigger than n cubed. Okay, since L11 is strictly superior than n cubed, so which means n is going to be in this set, number 1 and number 2. Okay, if we replace n with number 1, I get 11 strictly superior than number 1. If we replace n with number 2, I get 8 here, which means 11 is strictly superior than 8. we cannot have n equals 3 because n is already exceed 11. That means our solution is going to depend on this one. So let's take two cases. If n equals 1, if you're going back to this expression, I get m. So I will have two cases. I get n equals 1, replacing n. So by using this fraction, I get m equals 11 minus n cubed. N will be replaced with number 1, is divided by 3, is multiplied by 1 minus number 1. This one is given as 10 over 2, which is 5. Okay, taking these found facts and insert them in above equations to find a and b. Okay, have the system of the equation. The product ab equals m, which is number 5. The second one, I get the difference a minus b equals number 1. Okay, so writing a in terms of b, I get here a equals 1 plus b. Taking this value of a, insert it into the second equation, I get here 1 plus b factor b equals number 5. This one implies since 5 is a prime number, which means the small number is taking the small number, big number is taking the big number. So I get here b equals number 1 and 1 plus b equals number 5. Taking this value of b and insert it into second equation, I get here 1 plus b equals 5, which means equation I get here 1 plus 1 equals 2, which equals 5. It's clearly it's a contradiction. Okay, so which I have checked two cases, none of those cases give us the solution. Okay, so which means we have no solutions for this equation. So I have undo this video. If you have any question or suggestions, put it in the comment section below. By the way, don't forget to support us with your like and subscribe. Thank you for watching. I will see you next video. Bye.